Hey, Algebra 2. Today we're starting with Lesson 2, which is Base 10 and Scientific Notation. This is fun because it should be quite a review for you guys. Algebra 2 going over scientific notation, which I assume you've been using for a little while. You know what scientific notation is. And then just Base 10 and what does that mean. So this will be fun. All right, in the last lesson you worked with thickness of a sheet of gold foil, a very small number, and some very large numbers that gave the size of a piece of paper that actually could be folded in half more than 13 times. Convert 0.28 millionth of a meter to centimeters and express your answer as a decimal number. I always have used what I was taught was like ladders to figure out how to do this, so I'll just go through it. So 0.028 millionth of a meter, so that would be 0.028 over 1 million. 1, 2, 3, 4, 5, 6 zeros, and that's meters. And I'm going to multiply that by 100 centimeters over 1 meter, because I can cancel the meters out and I'm left with centimeters on the top. I don't know, that's just how I've always learned it. So if we look at 0.28 times 100, that's going to move my decimal place over 2 spots, and that's over 1 million, 1, 2, 3, 4, 5, 6. So that gives me points. That means I need to take this decimal place and move it over 6 spots. 1, 2, 3, 4, 5, 6, I think. 1, 2, 3, 4, 5, 6. Yep. Centimeters. So I did that without a calculator. That always makes me sort of happy. So express your answer as a decimal number. There we have, decimal number. The length of a piece of square notebook paper that can be folded in half 13 times is 3,294.2 inches. Use this number to calculate the area of a square piece of paper that can be folded in half 14 times. Round your answer to the nearest million. All right, so if it's going to be folded in half 14 times, I think I need to double this paper. So we have 2 times 3,294.2. So that's the length. And the area is going to be squared, right? I'm using my calculator for that one, sorry. 2 times 3,294.2 equals, square that, and I have 43407,014.56. I'm not sure what to do with that yet, so give me a second. It says round your answer to the nearest million. So add some commas. That right there is the nearest million. So we're going to say 43 million. There we go. Okay, we square inches. Next one. Match the equivalent expressions without using a calculator. Okay, here's a little test. Let's see. Here I have 0.6, which is the same as 6 times 10 to the negative 1. 3.5 times 10 to the negative 6 is a small number, so let's do this one. 1, 2, 3, 4, 5, 6. Ooh, there we go. 3.5 times 10 to the 6th is a big number, so let's count this one. 1, 2, 3, 4, 5. Nope, that's not it, but that is this one, isn't it? And then we have 1, 2, 3, 4, 5, 6. And then last but not least, I have these two left. That was fun. right, so why are we doing this? We're reviewing scientific notation because it's going to help us build into our exponential functions, which gives us a lead into logarithms. So for this one, write each number as a product of a decimal number between 1 and 10 and a power of 10. So I have to change 234,000 into a decimal number between 1 and 10 and a power of 10. So what we really have here is 2.34 times 100,000, right? So this right here gives me 10 to the 5th. So 2.34 times 10 to the 5th. So this right here is a number between 1 and 10 and a product of a power of 10. If I said 23.4 times 10 to the 4th, this is not between 1 and 10, so it doesn't work. Let me get, sorry, I hit the pause button on accident. Another way to explain it, 234,000, there's always a decimal here at the end, sort of like when we have a variable, there's always a number 1 in front of it, but we never talk about it, right? So I'm going to grab that decimal and move it back 1, 2, 3, 4, 5, and put it right there. And because I made a bigger number smaller, I can say that that's equal to 2.34 times 10 to the 5th. Okay, that's how I learned it. I didn't learn it by separating the numbers, but that's okay. A lot of people's minds work in different ways, so separating the numbers we can do. Let's try this next one, B. I can take this and say it's just like 35 over 1, 2, 3, 4 zeros, right? Or if I look at I need between a number of 1 and 10, that's like 3.5 over 3 zeros, which is the same as 3.5 times 1 over 1,000, which is 3.5 times 10 to the negative 3rd. Or if I go back to this method, I'm moving it 1, 2, 3 places. 3.5 times 10 to the negative 3rd. Okay, the method up here is a method that translates to a lot of other things we do in math, and it's important to know how the numbers work. The method down here are little tricks that I learned growing up, but I love how we explain how the math works up here, because this just relates to other problems that we do in life, and if we can understand how the numbers work, then if we get a funny application problem, we can attack it really easily. Okay, so let's do this next one. 5, 3, 2, 1. I'm going to put a decimal there and say it's times, let's see, we've got 3 zeros, 6 zeros, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So that gives me 5.321 times 10 to the 8th power. Let's try this next one. Count the zeros. I've got 1, 2, 3, 4, 5, 6, 7, 8 zeros, but I want a whole number, so 9, 10. So I'm going to do 12 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which I need that to be a decimal there, so I'm going to take away a 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm at 1.2 times 10 to the negative 9th. And this last one, I'm going to move it 2 spots. So it's just like 3.331. Actually, I'm not moving it at all. Silly me. I didn't move it. So it's times 10 to the 0. Ha 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 ha. All right. summarizing, a positive finite decimal s is said to be written in scientific notation if it's expressed as a product d times 10 to the n. S, so we have S, is said to be, is written in scientific notation if it's expressed as a product d times 10 to the n, where d is a finite decimal. It has an ending. And it's between 0 and 10, and n is an integer. It can be positive or negative, it just has to be an integer. What's cool is n, the integer n is called the order of magnitude. Okay, we're going to get into some application problems that talk about magnitude, and that's what we're going to use to sort of compare magnitudes. Okay, here's some exercises. Go ahead and try these on your own. I'm going to write the answer down, see if you can get the same answer. I love how they gave us some clues there. I thank them for that. All right, there you go. Go ahead and check your work. See if you can get the right answer, or see if you got the right answer, and then circle it if you're not sure what you did wrong. Okay, try these. I'm going to push pause. There you go with these. I would like to point out that I did not write 4.0. That's not right because you don't know what's after that 4. So you'd have to cut it off at a 4. There's just, you don't know what's after it, so you can't put this. This is inaccurate. Okay, exercises 7 and 8. Now we're going to do some math with some application problems, with our lesson. Change our numbers into scientific notation, which will actually help us compare them a little bit better. Okay? So use the fact that the average distance between the sun and the earth is that number. The average distance between the sun and Jupiter, and the average distance between the sun, that's messy, the sun and Pluto. Express your answers in scientific notation, where d is rounded to the nearest tenth. So distance from sun to earth, I'm going to do 1.5 times 10 to the 3, 6, 7, 8 times 10 to the 8th kilometers. The distance from the sun to Jupiter is 7.8 times 10 to the 3, 6, 7, 8 kilometers. And the distance to the sun to Pluto is 5.9 times 10 to the 3, 6, 8. Nope, 9. Cool? All right, remember these, write them down. We're going to need them on the next page, and you'll have yours in front of you. Mine is moving to the next page. How much farther is Jupiter? How much farther Jupiter is from the sun? That's poor English. Than Earth is from the sun. So we're going to do that is the distance of the sun to Jupiter. And here we have the distance of the sun to Earth. Okay, handy dandy calculator, because I didn't write these in the right way that I could do them by hand very well. That gives me 628, 911, 002 kilometers, which in scientific notation is 6.3 times 10 to the 8th kilometers. How much farther Pluto is from the sun than Jupiter is from the sun? Let's do a little bit more math. Make sure I got all those numbers in there. Yep, minus 780, 179, 470. gives me 5,127,859,654 kilometers, which simplifies to 5.1 times 10 to the 9th. Cool? Next page. Order the numbers in exercise 7 from smallest to largest. Explain how writing the numbers in scientific notation helps you to quickly compare and order them. Well, you have the numbers written in front of you that are already in scientific notation. I remember this one was a 10 to the 9th. So that's going to be our biggest, right? Then we had the distance, part E, gave us an answer of 5.1 times 10 to the 9th. Also a 10 to the 9th, which is important. The rest of them are 10 to the 8th, so let's just put them in order. I have 7.8 times 10 to the 8th, which was the distance from the Sun to Jupiter. And then 6.3 times 10 to the 8th, which was the how much farther Jupiter is from the Sun than Earth is from the Sun. And then the smallest one we have is the 1.5 times 10 to the 8th, which is the distance from the Sun to the Earth. But if you see, it's way easier to figure it out because I'm just comparing the numbers in front, right? These are all 10 to the 8th, so all I have to do is compare the 1.5, 6.3, and 7.8. And then we have all the 10 to the 9ths, so I just have to compare those two numbers. Super easy. Okay, remember, that's called magnitude. So the 9th magnitude is bigger than the 8th magnitude, right? Good job. Let's look at something else. Arithmetic operations with numbers written using scientific notation. Let's look at how we do this first one and see if it'll just make things easier for the second and third. Here, oh goodness. I have 10 to the 20th and 10 to the 21st. If I get those both the same, then it'll be a lot easier to do the math. So here, I'm going to change everything to 10 to the 20th. No reason. Plus, it'll be 45 times 10 to the 20th. So now it's almost like I have like terms, so I can add everything together. It's going to be 47.4 times 10 to the 20th, which I then need to say 4.74 times 10 to the 21st. So to be able to move your exponents, your powers of 10, up and down quickly will make it a little bit easier for you to figure out. For this next one, you're multiplying. I'm actually going to grab these two and multiply them, right? And then I'm going to combine these with our power rules that we've learned. If you remember, when you multiply like bases, you add the exponents. So that gives me 30 times 10 to the negative 4th. Oh goodness, if I could only add, or sorry, multiply. Silly, silly me. Which gives me 3.5 times 10 to the negative 3rd. Okay, let's try the division. Okay, division may be a little trickier or it may not. I can actually split that. And I have 1.2 over 3. And then if you remember, when I have powers, I subtract. So this would be times 10 to the 15 minus 7. 1.2 divided by 3. That actually gives me 0.4. You may see that easily. Times 10 to the 8th, which is 4 times 10 to the 7th. Cool, you got one example of each: addition, multiplication, and division. Why don't you try these on your own, and I'll write the answer. See if you can figure it out in a similar fashion. Okay? All right, check that out. See if it makes sense. If anything doesn't, please circle it and ask me when you see me tomorrow. Last problem, estimate how many times farther Jupiter is from the Sun than Earth is from the Sun. Estimate how many times farther Pluto is from the Sun than the Earth is from the Sun. So let's do Jupiter and the Earth first. Jupiter to the Sun was 7.8 times 10 to the 8th. And then the Earth to the Sun was 1.5 times 10 to the 8th. Since I have the same magnitude, I just need to compare these numbers. So if I look at it, I need to, how can I get from 1.5 to 7.8? Well, 1.5 times 5 is 7.5. 1.5 times 6 was 9. So we can say how many times further? You can say about 5 times. Okay, because they're the same magnitude, we're just comparing the other numbers. Pluto is approximately 5.9 times 10 to the 9th kilometers from the Sun. So we're doing Pluto and the Earth. So Pluto and the Earth. I'm not the same magnitude, so I need to change it, right? We're going to do 59 times 10 to the 8th to get the same magnitude, and 1.5 times 10 to the 8th. That gives me about 39.3 times as far. And that reminds me, we could have done that over here. 7.8 divided by 1.5. I just started guessing with numbers, sorry. 7.8 divided by 1.5 gives me 5.2. Easier to figure out, right? All right, that's all for today. Good work. We'll see you next time.